Welcome to Spring LIB.
This is chapter 37, problem number 50. We have a particle that is under the effect of a force that is directed from the positive x-axis 30 degrees. But what we're asked is actually the direction of acceleration that the particle is experiencing when it is moving, when the particle is moving in the positive x direction at a speed that is around 70% of the speed of light. So at that instant, we want to know the direction of the acceleration. So the force has obviously two components, right? The component of the force, let's get rid of this velocity here. But let's talk about the x component of the force, F sub x, we're going to call it, and the y component of the force, we're going to call it F sub y. Now, in our case, F sub x is going to be responsible for generating the acceleration in the x direction. So when, if we didn't have a relativistic approach, we would do m times a, but we can't do that anymore because our speed is very high. So then I suggest that you go and visit the equation 37.32 on your textbook, that you're going to see if the force is along the velocity vector, then the relativistic force is going to be gamma cubed times m, m being the rest mass, of course. This is only for the motion, only for the force, if your force is along the direction of the velocity vector. This is what is happening in the x direction. However, in the y direction, as you can see, this is independent of the direction of the velocity vector. So again, equation 3732 tells you then the force is going to be gamma factor times the rest mass times the acceleration in that particular direction. So we have two different components to figure out. Now, if we want to know what a sub x is, right, we can divide both sides by gamma cubed times a, gamma cubed times m. Sorry, gamma cubed times m. So then we're isolating a sub x, f sub x divided by gamma cubed times m. We said, well, from trigonometry here, f sub x is going to be equal to cosine 30 times the f vector. So f cosine 30 over gamma cubed. So let's leave the gamma cube aside. Let's write down the mass here, the rest mass. Gamma cubed, let me give you a reminder here. Gamma is 1 over square root of 1 minus v squared over c squared. Since we have the gamma in denominator, I'm going to actually flip this and I'm going to add it as a multiplier into the equation. So it's going to be square root of 1 minus v squared over c squared cubed. Right? So from here, since we're not given f or m, I'm going to leave my answer in terms of f over m, but I can calculate the gamma portion. So f over m, now I have cosine 30 here, and then I'm going to have square root of 1 minus v is 0.7 c squared over c squared, and the cube of this. If you do the algebra, what you get is 0.315 times f over m as the acceleration in the x direction. Now let's calculate, remember this equation, the acceleration along y direction. So on a new page, acceleration along y direction is gamma factor m a y. We're trying to figure out a sub y. So I'm going to divide both sides by gamma times m. So a sub y is going to be f sub y divided by gamma times m. F sub y, again going to the first page, f sub y here is sine 30 times f, right? So then f sine 30 divided by m, and I have 1 over gamma, so I have 1 minus v squared over c squared. As you know, this v is actually 0.7 times c. Let's just plug it in there, and we're going to take the square. When you do the algebra, again, write everything in terms of f over m, because those are not given to us. It's going to be 0.357 f over m. Now, we're asked the direction of the acceleration, the total acceleration, okay? So how are we going to do this? As you know, if you know the components of a vector, in order to get the direction of that vector, we get the help from the tangent of that angle. That is going to be equal to the y component of the vector divided by the x component of that vector. Now, we have then tangent inverse of tangent a sub y over a sub x equals to the angle that we're looking for. So tangent inverse a sub y is 0.357 f over m divided by 0.315 f over m. F over m is going to cancel each other out. We're going to find our angle to be 48.6 degrees. So remember, this is an instantaneous direction for the acceleration as the particle is moving in the purely positive x direction.